Hello everyone. We had seen principal component analysis (PCA) in our previous lecture, right? In this session, we're gonna understand the practical implication of PCA. In that lecture, I haven't shown you any, practical demo for that. But in this session, we will see a small demo on PCA, and you already know that PCA is used in dimension reduction in unsupervised learning, right? Throughout this chapter, unsupervised learning, we will use this PCA as our, you can say, the core concept, so that we can build up, the solution for more critical problem of machine learning. So we're gonna see the practical demo of PCA and the usual library that we use for any machine learning algorithm. We're gonna use the same library here, right? So I'll use the data set. I don't have any CSV file or any other, but I'm going to use the inbuilt data set of scikit-learn, that is breast cancer, where we have some malignant tumors and we have benign tumors, and we're gonna see how we can reduce that data set to an extent, right? We are not going to use any classification or any prediction algorithm to predict something or to classify something, but instead we're gonna use a reduction algorithm, okay, PCA. We will reduce the data set size, data set dimension, so that we can then use that data set for prediction or for any classification purpose. Okay, so I'm going to use, I hope you can see it. I don't think I can resize it because let me just, yeah, I can do this. Okay, and I think I can do this too. So I'm going to import the libraries here. Import matplotlib dot pyplot as plt. This library is basically used for our graph. So we're gonna create our graph with the help of this matplotlib library. Okay, and then we're gonna import pandas as pd, import numpy as np, import seaborn. I don't think I need this seaborn. Yeah, I need heat map, so because of that I had to import this library as well. So import seaborn as sns, and then uh, the usual inline for Jupyter Notebook. Okay, so these libraries are being pretty much imported now, and now I'm going to import the data set that I need. So from sklearn, so the data set is inside the sklearn data set. So sklearn data sets, and then import load underscore breast underscore cancer. Okay, this is gonna load the data set, and then I'll say I'll use the variable as tumor equals to load breast cancer. So I'm going to use this variable tumor to load my data set, and you can check it out, tumor dot keys, that what kind of the keys they have, what kind of attributes this data set possess. So it possesses data, target name, description, feature names, and file name, right? So I'm going to use tumor dot DESR, or let me just print it, print cancer. And to use this keys, I'm going to use square bracket, and I'll say DESCR, and you can see that yeah, the cancer, instead of cancer I need to have this. So you can see that it have 569 instances, and basically it having the 30 attributes, so it is 569 cross 30. Okay, so it is this could be rows and this could be columns. So this is completely 569 cross 30 matrix. Okay, so I want to reduce this 30 to some lower dimension, and we're gonna see that. Okay, so you can see we have a malignant and some benign um, uh, classification. These are the classes, and for classification algorithm you just have to classify it with the help of this malignant and benign. Okay, and these are the different statistics the mean, standard error, and other stuff. So we have 212 malignant and 357 benign samples inside the dataset, and these all are the information about the dataset who had created other references and stuff, right? So we'll see the next thing. The next thing is we have to create a data frame so that we can cut out the data and cut out the feature name. Okay, so I'll use df for data frame, and I'll say pd for pandas, and I'll say data frame, and I'm going to use again tumor, and I need the key as data. So I'm using the key data, and the next thing is I need a column. So this is going to be like rows and columns. So this column I need is tumor, and I'll use feature. What is the name? I just have to see that. So we have, I think, feature name underscore name, right? So I'm going to copy it and then paste it here. So this is my second key, and this is basically row and column. So my data frame is now having data and a feature name, and I'm going to use df to see that. Oh, I actually, df will give me all those 569 samples. So to cut it down, I'll say df dot head, and then you can see only 5 of them. Okay, so you can see here there are 5 rows and 30 columns. So it is a 30 dimension. Okay, 30 dimension. To visualize this, I need a 30 dimension space to represent all these numeric data point, and this is not possible for me. This is in high dimension space. I cannot do it. The dimension that we can do is we can go for 2 dimension, 3 dimension, or maybe to certain extent we can go for 4 dimension. But to go for like 6, 7, it is going to be pretty hard for me. It is going to be very complex for me. I cannot do that, right? So I need to reduce this higher dimension to a lower dimension, and more precisely I need a 2 dimension to represent it. Okay, I can see that. So I'll use now PCA to reduce this dimension. But as I told you in PCA chapter that before go for PCA, you need to do something called as feature scaling. Okay, and you know that feature scaling is basically used to make the correlated data or correlation. So if this particular column is having 100, 100, 122, 132, 130, but this column is having like 1000, 2000, 4000, then these features are not going to be like correlated. I need a correlated data. So I have to reduce this 1000 to an extent of 122, or this 2000 to like 100, like this 3000 to like 110, like that. Okay, I need to reduce that numeric data to so that these 2 columns, or these many columns, these 30 columns, are get correlated with each other. That is the feature scaling. If you don't know, then please refer the notes that you have, and they have the great explanation on feature scaling. Okay, we had seen the range problem there, so you already know that. Okay, so I'm going to use feature scaling before going for this reduction, this PCA. So I'll say so I have to use standard scaler for this feature scaling. So I'll use from sklearn dot pre-processing. Actually, we are doing pre-processing here. This is not just for this feature scaling. It can be used to do for it can be very helpful for noisy data also. If you're having any missing column, if you have null values or like that, I can use this pre-processing there also. So from sklearn dot pre-processing, I'm going to import standard, and then I think if this takes the tab, it is not taking, yeah, it takes. So it imported the standard scaler here, and I'm going to use a variable scaler here, and then I'll say, so the standard scalar function is going to be assigned to scalar now. So again, so scalar is now have all the function, the parameters that is there in the standard scalar. It is now with the scalar we have. Okay, and then I'm going to use this scalar to fit my data frame. I'll just use scalar dot fit, and I'll say the f, and that's it. Okay, you can see we have a mean as true and standard deviation is equals to true. So your data frame is being now scaled. Okay, it is being scaled. Now I need this scaled data to be transformed again inside my data frame. So what I'm gonna do, I'll use another variable to do it. So I'll say scale data equals to scalar dot transform, so that it transformed inside the data frame again. So df, and you can see that I'll call the scaled data, and that's it. Okay, so it is not going to be viewed properly, but now all these values, can you see the values are very nearby to each other, like 1.26, 2.29, 1.68, 1. They are very near. We don't have any value like 1000, like 2000, like 3000, or 100, 200, 300. We don't have that. You can see all these values are in the decimal format, 1.0, 1.2, minus 2.0, but here you can see we have larger values here, 1000, 1300, 132, like that. But we have scaled it, we have transformed it again inside the data set, so that we have a feature scaling property here. Okay, and now I'm going to use my PCA. So this part is going to be actual PCA now. So I'll use again a library to import the PCA from sklearn. So from sklearn, I'm again going to use, so you can see that we are using dimensionality reduction, we are reducing something, and that's why I need a special library for that. So we scale the scikit, we have decomposition. Okay, we have decomposition to import the PCA. Okay, so this sklearn is having decomposition specifically meant for in reducing the data set. We have this decomposition, and inside that we have PCA. So I'm using this sklearn.decomposition. Inside that we have PCA. In a very similar way, we have LDA and factor analysis, which is also inside this library. Okay, so I'll write PCA equals to, now PCA, if I can use shift tab, but however, yeah, you can see PCA is giving you some tooltip here. So PCA needs what it needs. It needs principal components here. So what kind of principal, how many components you need? So I'll use 2, and this is the complete description for it. You can check it out if you have, if you are pretty much interested. So you can see all this documentation here, and we have pretty much good references. You can also see the example that they had shown you here, that you can see PCA n components equals to 1. They had taken 1. I'm going to use 2. Okay, and then what I need to fit my data frame, or whatever the column that you had taken. Okay, and then you will see that that it is not being shown over here, but it is going to reduce the data set column. Okay, the dimensions, it is going to be reduces. So PCA, and I'm going to use n underscore components, and I'll say 2, and then I'll say PCA dot fit. PCA dot fit, what I need to fit is the scaled data, this one. Okay, so I'm going to copy this. So I need to copy this, and I'll paste it over here. So I'm using PC on the scaled data here, and I'm going to hit OK, and you can see it has been processed here. And now I'm going to use something called as transform to reflect into the scale data. So I'm going to use PCA new equals to PCA dot transform, and I'll say scaled data. Okay, and this PCA new, again you can check it out, that PCA new had completely scaled down it. And if you want to see the thing, then we can compare this PCA new with the scale data. So we can have the shape function here. So scaled data, if you see scale data dot shape, if you see here, it is 569 cross 30 dimension. So it is the row and column, so it is of the 30 dimension. But now if you see PCA new dot shape, you can see that it is 569 cross 2, so it is 2 dimension. So we have reduced this from 30 dimension to a 2 dimension. Okay, it is easy for me to visualize it now, and for visualization purpose, I can use the matplotlib here. So I'll use matplotlib to create this graph. So I'll use plt.figure to size my figure. So I'll use figure size to get a canvas of figure size equals to, I'm going to use 10 by 8, and then I'll say the scatter. I'll use plt dot scatter function to get my PCA new, and I'll use the column and rows. So this is the rows and column, and the other thing is PCA new for the other component. Okay, so these are my principal component 0 and principal component 1. Okay, these are the two principal component that I want, and c equals to, I'm going to use tumor for my column name target. Okay, so I'm making this out, this principal component 0 and principal component second on the column name target. I'm using this feature target, and I'm using this principal component 1 and 2 on that column. Okay, so when you, I need another line for labeling it out. So x label equals to, x label equals to first principal component. Okay, and I'll just copy this and I paste it for y label. So this is second, and when you run this, you will see that, and you can see this is the target, and it is easily being, just to resize it, it is easily classified here that these are the two principal component, by the way. So this is my first principal component, this is second principal component, and what I precisely wanted, I want to see these principal component. And what you can do is you can simply write here PCA new, or just PCA dot components, and PCA components, and you can see these are the principal component values that is there inside this first and second principal component. Okay, now you can use any classification algorithm to separate out. These are two clusters that you can see, and it has been reduced from 30 dimension to 2 dimension only, and now you can have a simple smooth line over here to just classify that this is the benign cancer and this is malignant cancer. Okay, this is the easy way. And what are these two principal components that we had taken? You can compare that, or you can grab that two principal component from your data frame. So I'm going to use df PCA equals to pd dot data frame, and I want my component, so I'll use PCA dot components underscore, I need column equals to cancer, column equals to tumor, and I'll use feature, all the feature names, and simply write dpca, and you can see these are the two principal components that I talked about, 0 and 1, that is there. This is first principal component, second principal component, and these are the values that I was talking about. So this is my mu actually, if I want to say, this is my mu1 and mu2, and they are correlated with each other. Okay, and these are two principal components 0, 1, and you can have a heat map to see that how these features are how internally they are correlated with each other. Okay, you can take a heat map and can check that out. So in this session you had seen the PCA practical implications, that how you can use any data set and how can reduce the data set dimension, and we had precisely seen that this 569 cross 30 dimension is being changed to 569 cross 2, that is higher dimension to lower dimension. Okay, so now you can use this this PCA here, this PCA new, to fit to any prediction algorithm or to fit any classification algorithm. Now you don't need to use the scaled data or the complete data frame here, this complete data frame, because if you do that, then there might be a problem. There might be a problem of dimension, the higher dimension, because you are using 30 dimension, which is not going to give you the aspect of result that you want. But instead of but instead of using DF, the complete DF, you can use either scale data, and more precisely, instead of using scale data, you use this PCA new. Okay, instead of using DF or the scale data, you use this PCA new, which is the lower dimension of data. Okay, now you can use for prediction algorithm or for any classification algorithm. I hope you understand it. Thank you so much for listening me. If you have any doubt, you can check me out on the comment section. I will be happy to help you. Thank you so much.